Okay, so we are doing some factoring, and this first one was 1 plus sign and 1 minus sign. This one was tangent plus 1 and tangent minus 5. How on earth do you factor that? Don't overthink it. Factoring just means breaking it up into two things that multiply to it, and it's just cosine and cosine. Why would you ever want to do that? Because what if there had been a divided by cosine in the problem? You would break it up like this so that you could go cancel, cancel, and the answer is just cosine. That's why you would factor a squared into two separate cosines. Okay. I want to give you another example of factoring that a lot of people just they just don't see it. Factor that. Don't looking for something super complicated. Just, do you see they both have sign in them? Factor it. So there's a base skill here. If you're not getting this, it's because back to algebra, there's something like this on the top 20. If you don't understand the base skill of factoring, then you won't understand this one. But this is the base skill of factoring. Do you get they all have an x in them? And if I factor out the x, I can see what's left. What could you do to see what's left? You could divide them all by x. And then you'd go, oh, I guess there's an a here, plus, oh, I guess there's a 2 there. And then these x's cancel, I guess there's a y there. It's like that. That's one of the top 20 skills. That's why I make you learn those first. And that's why some of you that still have a bad top 20 score, because you haven't worked on it, Algebra Ninja has been there the whole time, you could have worked on it, are going to not get something like this. Because there's a sign in both of them. If you take the sign out, to see what's left, you could divide both parts by sign. In the end, it's a lot like that. And these turn into 1s when you are reducing them. And then you got 1 minus cosine. Who actually had that one right? Raise your hand if you did. Do you get now what to do? It's going to be another one like it. Do you get they both had a sign in them? So I factored it out to the front. All right, let's do another one like that. Tangent minus cosine tangent. Factor it. Okay, compare it with the kid next to you. Right over there.
Yeah, it's better.
So are you saying that it should does that?
Yes, I actually tested the equipment.
Good. That's pretty cool. It's fascinating.
I'm not going to claim that I totally understand what you just said, but changing space and time, pretty impressive. Okay, did you notice there was a tangent in both of them? Winston, tangent comes out. What do I have left? 1 minus cosine. That's all there is to it. Who had that one right? Oh, good, now we're up to way more than half. Okay. All right, so, and if you're like, I still don't get that. Well, you can at least get they both have tangent, and then you divide it, both of them by that, to see what would be left if you factored that tangent out to the front. And this simplifies to a 1, and this part simplifies down to a 1 also, so it's just cosine. Okay, and the next problem I want you to try is one that involves common denominators. Everybody try changing cosecant theta minus cosine squared over sine, and that will simplify way down. This is not a factoring one, this is a simplify one. Now, I know that at first this might be like, I don't even know where to start. Do you get that there's two fractions here? It's just this one has a 1? And do they have a common denominator right now? No. So then you have to get them to have a common denominator. All right. Turf, what could I multiply the cosecant by that will get it to have a common denominator? Sine. But can anybody think of a faster way than multiplying it by sine over sine? There's a really simple way we can do it. Ava? Cosecant is 1 over sine. You are correct. I can replace this with 1 over sine. The other way would have worked, it just would have had way more steps. Now they've got a common denominator. Now you can put them together into 1. Ainsley, what's on top of that? 1 minus cosine squared, yes. What's on the bottom? Sine. Notice not squared. I messed that up earlier today. These do not multiply. They're just the common denominator is sine, so you leave it as sine. It's not sine squared. All right. Now, I'm going to state a fact off the sheet. This is a reminder that you need that sheet. Sine squared plus cosine squared equals 1. There's something about that that should inform you on what that should change into. Since sine squared plus cosine squared equals 1, you can do something to this fact, like maybe subtract something on both sides, and you'll have your answer on what to put in for the top. All right, this is the part where I've got extra half sheets. Literally, they're just going to be recycled after today, so I'm happy to hand you one. If you've already got one, awesome. I don't have quite enough for everybody. But I'm going to walk past and give you a half sheet of facts you can use on this test. Okay, so this is a fact off the sheet, and you should be just like really good at recognizing, oh, it's got the 1 minus the cosine thing. That's this, but rearranged. So you go minus cosine, because you know you want 1 minus cosine. And if you subtract cosine from both sides, you'll realize that sine squared is equal to 1 minus cosine squared. And so that means I can replace this with sine squared. But I'm going to right off the bat break it into 2 sines, just because I'd like to save a step. Sine is the same as sine squared, because this is a nice logical way to get that to cancel, and your answer was just sine. Who had it as sine before I said it? Okay, good. So, one more that I would like you to try and try and get common denominators for. Common denominators is huge on this upcoming test. So since I'm telling you this is about getting a common denominator, what would the logical denominator be? Rissy, do you know? Well, they have 1 right now as a common denominator. I know, you're right, but we need to change to something other than 1. What's the sister of secant? Not cosine. Oh, it is cosine. Sorry. Yes, so this is equal to 1 over cosine. This part right here, 1 over cosine. What's the sister of tangent? Cotangent. That doesn't help because they don't have a common denominator. But what if I used the other thing that tangent was? Sine over cosine. Now, do they have a common denominator? Yes, they do. Do you get how before they weren't even in a fraction? Or you could say their denominators were 1. Now their denominators are cosine. So then, it's cosine squared on the bottom and sine squared plus 1 on the top. Hint. Oh, wait a minute. Oh, I think I should have made this a minus. Nope. This is fine. I remember this in last hour. And some people just assumed, oh, so that's cosine squared. No, it's not. What's that statement about sine squared and cosine squared? Sine squared plus cosine squared is equal to 1. So is 1 plus sine the same as cosine? No, it would be 1 minus sine squared. Cosine is 1 minus sine squared, so you cannot replace that with cosine. That would be your answer. But do you remember me saying that you can't have a denominator that's a function? Everybody, somehow, you can't just move cosine to the top, but somehow get that out of there so that it doesn't have a denominator of cosine anymore. Like, we better finish this thing by replacing it with something. So, Marin, what is that? Replace cosine with 1 over secant. Cosine and secant are sisters. So then the secant can go up on top. So there's some skills that you need to be able to handle this this upcoming test. We did some factoring. We did some common denominators. Now, I'm going to give you a whole bunch of time to work on 3 questions. Turf. Could what be what? Which part? Okay, well, the original problem was tangent squared plus secant squared. So I'm pretty sure that it would not equal tangent squared plus 1. Thank you for trying. Okay, now there's 3 questions. And the nice part about the problems I'm about to give you is that it's proofs. Yes, and the proofs, you know what the answer is. It's just, can you get there? Question.
For the last problem, why couldn't you do sine squared plus 1 equals negative cosine?
Ooh, good question. Yes. There is more you could do to simplify this. She's asking about sine squared plus 1. Could you replace that with something? Well, the simple answer is not exactly that. No, you can't just replace this with something because we already investigated this. Sine squared plus cosine squared equals 1. But if I do get the sine and the 1 together on the same side, that would be by subtracting sine squared. This is what we could have done is if there had been a 1 minus sine squared. Now, what you're thinking of is if you factor out a negative 1 from this, but the problem with that is this one turns into negative sine squared minus 1. So it doesn't exactly work. See how this and this are not exactly the same? So, nope, I can't swap those out. Okay, so I think we need to get to the little group quiz. These two rows slide right next to each other. These two rows slide right next to each other. You guys know how to do this. And I will go through these problems at the end of the video, so I'm going to pause while we work on them. I want to give 2 hints before I give out the answers. On number 3, the way that's easiest, if you got it to work already, awesome, don't change it. But if you're stuck and your way wasn't working, I've seen 3 possible ways you could go. I would change on number 3, I would change your cotangent to, somebody predict what I'm going to say. 1 over tangent. Plus tangent. And I get that may not be like your first choice, but do you agree cotangent is 1 over tangent? It's true, isn't it? And then I can get them to have a common denominator. Remember me saying that over and over again? How do I get them to have a common denominator? Multiply by the right thing there, and then notice you have 1 plus tangent squared, which is right on the sheet. All right, there's my hint for number 3. Another hint I have is in number 2. In problem 2, everybody look at problem 2. Did you notice the minus sine squared and the minus cosine squared? And think to yourself, dang, I wish that was sine squared plus cosine squared, because then it would be equal to 1. Do you get you can factor out a negative 1? If you forgot how to do that, divide them both by negative 1 and see what you get. You can factor out a negative 1 right there on number 2. I will show you the rest of the answers in a minute, but I want to give you that clue for hints on how to do problems 2 and 3. I think most of you figured out number 1. If not, that's all right. I'll be showing you that in a minute too. All right, so I'm going to work through these. And our first step on the first one we did in class is to recognize that cotangent can be replaced with, well, it's one of the things on the sheet, cosecant minus 1. There's not many places you see cotangent squared on the sheet. And if you arrange that one, you'll get cosecant minus 1. And then that's good because cosecant minus 1 is cosecant plus 1 and cosecant minus 1. When you factor it, on the denominator of that one, we had cosecant plus 1. And now we're going to be canceling these. Have a seat, please. And now I have cosecant minus 1. And that's what I was supposed to prove. Look at that. It's equal to cosecant minus 1. On number 2, I had given the suggestion that you should notice that if that was sine squared plus cosine squared, it would work out really nice. Sine squared plus cosine squared. And it is sine squared plus cosine squared because once we factored out the negative 1, that's what we have. And then I'm going to replace that with a 1, of course. And so this whole side over here becomes negative 1. Over here, oh, by the way, we're supposed to prove this all equals 0. So over here, this side is going to equal 1. So I'm going to replace my cosecant squared with one of those facts right off the sheet is 1 plus cotangent. 1 plus cotangent squared minus cotangent squared. The plus cotangent and the minus cotangent cancel each other out. And look at that. We have 1 minus 1, and that is equal to 0. Yay, it worked. Okay, and last but not least is I've changed cotangent to 1 over tangent, and I now have to get a common denominator between these two. And this one is going to multiply by tangent and tangent, and that'll make this into tangent squared. So I now have 1 plus tangent squared over tangent, and 1 plus tangent is one of those things that's right off the sheet. You see how often you use that. Secant squared over tangent squared. And at that point, I'd understand, like, looking up and trying to figure out, what am I trying to make this equal? And I already have a secant squared, which is in my answer. That's what I want it to be. It's just I have to have a cotangent in my answer, so looks like I better try to change this tangent into a cotangent, and it will. Tangent is the same as 1 over cotangent. And so now I've got secant squared on top, and I'm going to make my secant squared times my, I'm going to move this up to the top and flip it over, so then it'll be cotangent on top over 1, and my final answer is secant squared theta times cotangent theta, and that's the same as that. So yay, I proved that that was equal. All right, there is written out key that you can look at in the Schoology folder for today. Those were tough, no doubt. But the test is not easy, no doubt. You should be studying for that thing. There's also a Schoology quiz that is due on the day of the test, which is going to be Wednesday. That's all I got for you for today.